Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on 8F. First one here is number 1. Sketch on the same set of axes the graphs of y equals e to the x and y equals negative e to the x. What is the geometric connection between these two graphs? So let's make our life easy. Let's put this in the graphing calculator. So we've got e, which is way down here. So it's second, and then this ln up above that is e to the x. So it's actually e to the, and we'll just put x in there. And then for this next one, we've got second, we've got negative, and then second e to the x. Okay, and then we'll just graph these things because we want to see what they look like. Oops, this was from an old graph here, so let's go back to zoom. Whenever your graph looks weird like this, go to, oops, it's still graphing. You got to go back to zoom standard. Okay, so go back to zoom and then hit number 6 for zoom standard. And now the graph should look a little bit more useful. Okay, so there's that one, and then this one here just dips down. Okay, what's the geometric connection between these two graphs? It's a reflection over the x-axis, isn't it? Okay, that's really that's the big thing on that one. Okay, number 4, evaluate to 5 significant figures the value of each of these. So in our graphing calculator or regular old calculator, you should be able to do the same thing. We're just going to do e squared. So we'll do second e to the second. Push equals 7 point, and it says to 5 significant figures. 1, 2, 3, 4, 5. That's the 5th, so the 5 tells the 0 to get bigger. 7.3891. That's 3 significant figures. Okay, and then e to the 2.31. Second e to the 2.31. Enter that in, and we get 10 points. There's 1, 2, 3, 4, 5. The 4 tells the 4 to stay the same, so 10.074. Okay, so that's the e's. Just putting those into the calculator and see what we come up with. Use your calculator to solve these exponential equations. E to the x equals 10. Okay, I would assume that we should be able to just put this straight into the y equals, right? Our two graphs here, because this is, again, it's not more than 10, so it'll show up right on the top of our graph. If this was more than 10, I'd probably subtract it from both sides. So it'd be e to the x minus 10 equals 0, and then put the 0 in as well. But we don't have to on this one. So let's just leave it. We've got, look, we already got e to the x there, and then this one we're going to just turn into 10. Okay, and then we'll graph those two things and see where they intersect. So here's the e to the x, and then 10 is going to be a red line that comes right across the top here, and we just want to find that intersection point right there. Okay, so second trace, we want to find 5, the intersection. That's the first graph. That's the second graph. Give it a guess, sure, and it gives us 2 point. Doesn't say where to go to, so I'm going to go to 3 significant figures, 2.30. Okay. All right. And then number 9. This graph shows the amount of water in a tank T minutes after it's punctured by a drill. Find the exponential model connecting A and T. Okay, so A is the amount of fluid in there in kiloliters, and T is going to be time in minutes. Okay, let's put some things in here that we know. We know that when time is 0, the kiloliters is 10. So we've got a point there, and we know that this A equals 3. There's our asymptote there. So we know that this C here has to be 3 because that's our asymptote. Okay. So now we got to figure out what some of these others are. Now look, this 0 is the time, and this 10 is the A, the amount in there, right? So we can actually, let's see if we can plug that in and figure out what K is, right? So A is 10 equals K times E, and remember E in this case is an actual number, negative 0.5 to the 0 times 0. Plus 3. Okay, so let's see, to figure this thing out here, we know that 10 equals K times, I'll put a dot there instead of the big X there, just to not be confusing. Negative 0.5 times 0, that's going to be to the 0 power, right? And we know that anything to the 0 power is just 1. So we get 10 equals K plus 3, right? Because that's going to be K times 1, which is just K. Subtract 3 from both sides, and we now know that K is 7. Okay? So now we should be able to write our model here. So this was part A that we just did here. So our model should be A equals 7, let's do, times E to the negative 0.5 T plus 3. There's our model that we can use for the rest of these questions. Okay? B, do you think the hole is in the bottom or the side of the tank? Explain your answer. Well, here's what I'm thinking. Look, this thing goes down. It's going down all the way until the amount is at 3, and it's pretty much stopping. So you know what my guess is for B? Guess what? I'm thinking that that hole is in the side. In the side. And that's 3 kilometers up. 3 kiloliters up, so to speak. So however high it's going to be to hold 3 kiloliters, that's where the hole's at, because it's going down, but it's not going down below 3 kiloliters. Okay? C, find the amount of water in the tank after 2 minutes. So now we can use this formula here, plug in 2 for T, and away we go. So we got A equals 7 times E to the negative 0.5 times 2 plus 3. So that amount is going to be, really, we can probably put this in just as it looks, but I'm going to just simplify this because it's going to make my life a little bit easier. E to the negative 0.5 times 2 is negative 1 plus 3. That's a 3. Not a pretty 3, but it's a 3. Second quit. Let's do clear this out, and we are going to do 7 times second e to the x, and that's e to the negative first, and then go over and then add 3 to that, and that should tell us how much is in there. 5.57. The 5 tells the 7 to get bigger, so let's go with 5.58. 5.58 after 2 minutes. 5.58 kiloliters left. Okay, so that's about right here. And look, there's, 2 minutes. Let's see. Well, there's 5. I guess that's probably closer to 5.58, but that's that point right there, 2 minutes. Okay? And then D, how long will it take for the tank to lose 6 kiloliters of water? So if it starts at 10, and we want to lose 6, 10 minus 6, we want to know when it gets down to 4 kiloliters. So here's our formula. So we want to plug in 4 for A, and that equals 7 times e to the negative 0.5 t plus 3, right? So probably the easiest way to do this is we can just plug these two equations into our graphing calculator, right? Okay. Now, if you wanted to, you could make these equations a little easier. Like I could subtract 3 from both sides and put 1 equals 7 times e to the negative 0.5 t. That would be fine. I'm just going to leave it like this just because that's what we have, but you certainly can simplify it if you want. Okay, 7 times second, and then we do e to the x, and then x is to, let's see, negative 0.5 times t here, times x. I know it's kind of messy looking up there. And then plus 3. And then we hit graph. And then let's see where these two things intersect. So there's our one graph. Let's see if our other graph, oh, that's 4. And let's see if our 7 times e to the negative 0.5 t, oh, look, it does show up, and it's going to intersect right there. So that should be pretty easy for us to find. Second trace, we're going to find the intersection, which is 5. Find the intersection of this line and that line, and we push enter, and we get at 3.89. Okay, so t equals 3.89 minutes, right, is when it's going to get down to about 4. So really we can also look at that by kind of going over here, Go down there. And look, that's just before 4, which is at about 3.89. So that I feel pretty good about that answer. Okay. All right, that's all we have for the 8F assignment. If you have any further questions, please feel free to ask. Thanks.